Welcome to my new video. Today I will show you how to analyze two-way data. If you design it in RCBD, then how can you analyze it by using R? Okay. First, you have to install two packages. First, install package read Excel, perfect. And then you have to, after installing, you can do library. After install, you have to summon read Excel. Yeah, right. First step done. And then what you can do, okay, so next we have to install another package. Install package agricoli super package. Okay, right. Then to summon library. Oh, here okay, perfect. Here you have to use right. Okay, right. Agricoli and then library, perfect. Okay, next we have to show the path from where R can read your data. For example, our data set is X is used for, then I have to read Excel. Okay, I have a problem here. I can write read Excel here, and then okay, that is my path tilde option, and okay, then backslash I keep it in desktop, perfect. Then again backslash, and then I'm showing you how can you arrange your data. Okay, this one. Okay, this one is arranged for two-way ANOVA. That means here we have two treatment. One treatment is variety and another treatment is control and water logging. So we have two treatment. One is variety is one treatment, and treatment control and water logging, this is another. So it will be two-way interaction, and it's done by RCBD. So use a replication, and each replication contain a single treatment, so we can use it as block. So this is how you can arrange your data, and the data name here variety two-way. Okay, and it's in desktop. So okay, copy it, and then where is our desktop? Perfect, right, two-way. Then let's see. Okay, it's two-way. Then we can check X data, right, shows the data, so everything is okay. After summon, we can check the structure of data. Structure of our data is for X. Structure, you can look closely that here replication is numeric, varieties factor, treatment factor, and our others are like what it called pH, dependent variable also number, and treatment variety interaction is factor. So we have to change this factor into numeric. How can we do this? So we have to modify variety and also treatment, because variety written in v1 v2 and treatment is written as CW, so we have to change it into the number. So for this x $, First we can work with treatment, and then it will be s dot factor, then x dollar sign treatment. Now it convert, right? And then we can do same stuff for variety, s dot factor, so then x dollar sign variety, right? Now it can convert from factor to numeric, and then we have check also interaction, right? That one you also need to change interaction, right? Then x dollar sign treatment variety interaction, so we can say treatment variety interaction, it will be interaction, right? INTERAC interaction, okay, interaction of x dollar sign treatment and x dollar sign treatment and variety, right? Now you can see, right, you find the interaction. Okay, done. Now you can check also, this is optional, you can check in which level interaction done, that is this one, sorry, okay, we can check the interaction. Yeah, this is the interaction level CV1, that is control variety 1, waterlogging variety 1, control variety 2, waterlogging variety 2, control variety. That is the interaction between treatment and our variety. Okay, now we can do analysis, ANOVA, analysis of variance. We can denote this as model will be AOV for ANOVA, analysis of variance. Then we can denote ANOVA, it will be formula data null project false. Okay, so our dependent variable is pH, that is plant height, and then tilde option, okay, tilde, and the right side of tilde will be the independent variable. So here first we can count about the block, that is the replication. As I told, this one is 2 ANOVA and also RCBD. So here the block is replication, and then treatment, and then variety, and then we will, so we are considering replication, treatment and variety. Then we have to consider treatment and variety interaction. So treatment and variety interaction is denoted as treatment variety, right? Treatment variety. So we can, okay, treatment variety, right? And our data is data equal, we consider data as x, right? Now you can run, yeah, everything is okay. Now we want to see the statistics, that's why you have to write summary, as you know, summary, summary, to check the statistics. Always we write summary model, that is the model. Okay, right, here is the ANOVA, analysis of variance. Here you can see replication, degrees of freedom, sum square, mean sum square, and then f value, and here p value. Also we check treatment, degrees of freedom 1, it is 2, that is n minus 1, 2, sum square, mean sum square, and then f value. Okay, and then it's highly significant p value, we have seen is highly significant, and variety also highly significant, and residue, that is the error, residue is 11, bear in mind, and mean sum square is 1.85. we need this for Tukey test or pairwise comparison. Okay, so then what can we do? Okay, now you can do the pairwise comparison, that is the pairwise comparison. 2 key HSD. Okay, you can do 2 key TUK 2 key. Okay, 2 key will be HSD.test. HSD.test, then it will be Y is for model, then treatment, degrees of freedom of error, that is the residue 11, and mean sum square, that is the 1.85 in our case here, and then okay, then we can check the alpha, and also group will be the true. So here is our model, and then okay, our this treatment, we'll check first treatment, the pairwise comparison of treatment, and then alpha equal to significant level will be 0.05, that is 95%, and then 5%, then group will be group equal true, it will be boolean true, right, and then our residues, degrees of freedom of residue, that is degrees of freedom of error, is 11, that is 11, and mean sum square of residue is 1.85, so 1.85, right, perfect. Yeah, everything is okay. Now we can check the groups. 2 key $, groups, row UPS groups, right. Okay, you find that here control and water logging is highly significant in case of plant height, as we are considering this. So control and water logging is highly significant in 5% level of significance. Then we can check the 2 key HSD.test. Now we can do it for variety. We want to check the significance level among the varieties. We have 3 varieties, so variety, right, and then our treatment. Okay, we have done variety, degrees of freedom of error, then degrees of freedom of MS, alpha, point, group tree. Okay, you can arrange in this way or maybe in the previous way, it will be the same. So we can copy it from here and just paste it. Okay, and it also work. You can write some 2 key group GROUPS groups, right. Now we check the significance level among the varieties, that is the variety are also highly significant to each other. We have seen different letterings here. What about the significant level among the treatment and variety interaction? This is also very interesting. 2 key HSD.test, and then model. We want to check the interaction between variety and treatment, so this is denoted as treatment variety interactions. So this is our okay, right, treatment variety interaction, and then everything will be like this, same. You can copy and arrange, and then 2 key groups, right, to be also same, right. Now we can check, yeah, this is the interaction between variety and treatment interaction. We find different lettering, that is we got the pairwise comparison among treatment and variety interaction, that is the two-way interaction in RCBD design. Okay, now we can check this in another also Duncan test, for example. Duncan test. We can check pairwise comparison. So DMRT will be Duncan test. Duncan test, TUNC, like Duncan test. Then the same way, like Y, that is the model, treatment, degrees of freedom, error, mean sum error, alpha, group will be same way. So exactly the same, you can take this. I am just showing you the interaction. So exactly the same way. Okay, then you can check DMRT. Perfect. DMRT. Okay, right. Now you have seen the interaction between the treatment and group in Duncan test. DMRT method is almost give the almost similar result like the 2K SST. The same way you can do also LSD test. Different pairs comparison, just to check about different test result. LSD, same, LSD dot test, and then this function is also more or less similar with the previous one, like Y, that is model, treatment, degree of freedom error, mean sum square error, and alpha will be 0.05, and then group will be true. So it's okay. We can copy paste here and then just paste here, and then LSD. Okay, perfect. So okay, yeah, right. So now you got the value in case of LSD test. So in this video I showed you how to analyze two-way ANOVA data. If you have two factor, one is variety and another one is different treatments, or in different way you want to see how these two factor interact with each other, then you can use this. This video is helpful for you. You can use the codes for R. Thank you very much for watching.